No, we're just warming up. Now we're going to start, you know. Bismillah ar-Rahman ar-Rahim. Well, thank you very much, first of all, for attending. I hope it will be worth your time, hopefully, you know. Today, we're going to talk about a basic, really, basic introduction to the world of artificial intelligence, specifically for engineering applications. The reason why I added the word for engineering, because there are AI applications in computer science, and AI application engineering. They're not really the same because in computer science they develop just computer programs. They are apps. But in engineering, we actually develop prototypes. We can make up circuits that work with intelligent systems, etc. So the techniques that the computer scientists are using, are slightly different from the engineering perspective. So is artificial intelligence a computer science area or an engineering area? Well, actually, it's both. It's both. There are certain things that computer science cannot do, and there are certain things that engineers cannot do. Okay, so that's why we are going to focus really on engineering applications. Actually, before I start, those of you who really want to have very, very basic introduction to artificial intelligence, those who can read Arabic, actually, I have two books, kind of old. The first one is called مدخل إلى عالم الذكاء الصناعي, which is just an introduction to the world of artificial intelligence. This is really for high schools, and it was distributed to almost all high schools at one time. This is slightly more advanced. This is called Fundamentals of Artificial Intelligence. This actually has some math. You know, this is good for maybe for the students. I added also another book that I wrote for MATLAB. The reason why I'm using this because MATLAB is the best platform to develop artificial intelligence techniques for engineers. See, for example, computer science, they use other programming languages like Python, etc. For us, MATLAB is probably the best application. It has so many toolboxes. It has so many toolboxes with all the different artificial intelligence applications that you can use, and it makes developing AI.
This book is a general introduction to MATLAB or from I?
You know, I could have titled this book MATLAB for the Dummies. And the American people.
But that title is taken, right?
Yeah, no, here it's misunderstood. American people understand it differently.
That dummy series.
Yes.
They are already.
So the way I wrote it is just you take your this book. It's a small book, you know, and you put your MATLAB in front of you, assuming that you have absolutely no idea about MATLAB. You know Windows, and that's it. So you open your MATLAB and you open the book and you just go over it, and you can cover almost everything in about a couple of hours. Basically, this is the idea. So anyway, this is just for general reading. This is in English. This is not very useful. There are tons of books, but I think these two books are the first two books written in Arabic in the whole Arab world. This is available on the internet. Somehow people copied it. I don't know. This was published by King Abdulaziz City for Science and Technology. You can find it available on the internet. This was done by Master Faisal, King Faisal, and then it was sold at one time in Jarir, and then I did not renew the edition. So I think this is not going to be available. I tried to look for it, but if you want to have soft copy, so there is no problem, you know. So what I'm going to cover in the couple of lectures that we have today and Wednesday is basically a basic introduction. Really, it has some philosophical flavor before we get into the real aspects of artificial intelligence. Then I'm going to cover a few artificial intelligence approaches. So we're going to talk about fuzzy logic, and then we're going to talk about neural networks. Most people know neural networks, and not everybody knows the others, even though the others could be even more useful, by the way. Then we're going to talk about genetic algorithms, and then swarm intelligence. I'm going to focus more on ant colony, very interesting technique. I also am going to talk about an expert system. It's not my favorite, but it's useful. And then I'm going to give some examples of AI applications from international applications. If we have time, I will give some examples of students' application. So the lecture is going to be very basic. The objective is, well, the objective I set for the lecture is to give an idea what's AI. So we should be able to define AI. We should be able to know what are the different AI approaches, where every approach is very useful to be used, and some ideas of how every approach is used, very basic, huh? So that if anybody wants to choose one and to go deep in it, I think you will have maybe a reasonable start. So we're going to start from the very basic aspects. Before the lecture, I asked this question: what's artificial intelligence? Everybody uses the word artificial intelligence. We know it's an intelligence that is artificial. Okay. The translation of artificial intelligence is الذكاء الاصطناعي. Some people mistranslate to ذكاء صناعي. It's not. الذكاء الاصطناعي is industrial intelligence. It has absolutely nothing to do with artificial intelligence. So اصطناعي مصطنعة. It's not real. It's not natural. It's something somebody said man-made. It is kind of man-made. The natural intelligence is God-made. The artificial intelligence is man-made. But before we define artificial intelligence, we know artificial, but we don't know intelligence. So if you know the definition of intelligence, probably we can define artificial intelligence. The problem that nobody can define intelligence correctly. There is absolutely no agreement on what is an intelligent creature. Even those people, scientists who are working for years in cognitive science, they disagree. Some people say, well, actually, being able to create connections between notions is an act of intelligence. Some other people said, actually, being able to think in abstract manners, that's a sign of intelligence. Some other people said, well, being able to solve a problem is a sign of intelligence. Some other people, learning is the key aspect of intelligence. So there is really no general agreement, but intelligence actually in that kind of space. Artificial intelligence, if we somehow agree on this, is basically an area that studies how to make machines do things at which, at the moment, people are doing it better. So if you can make the machine do something like what we do well, that's artificial intelligence. Another definition may be AI is a science whose purpose is to make computers and other machines in general acquire the quality of intelligence and have the ability of thinking, learning, creating, and communicating. These are very, very important concepts. So if a machine can think, well, we'll talk about what's the meaning of thinking. If a machine can think and learn, create, and creation is a very complicated concept, and communicate, then we say that this machine is intelligent. Now, ChatGPT is doing this, and people are being impressed with just one component out of these four components. Some funny definitions that I used to read before, they define artificial intelligence is to make machines behave like those in the science fiction movies. As simple as that. You watch science fiction movies, right? Like Matrix, AI, and all that stuff, very long time ago. So if you can make a machine behave like those science fiction movies, that's artificial intelligence. So as simple as that. So people approach the idea of AI systems in many different ways. The most common three ways is dealing with systems that think like a human. Now we're taking a little bit of philosophy here. I think it's very important to start the lecture. So thinking like a human, or acting like a human, or acting rationally. So which one of them could really represent artificial intelligence system? They are different because thinking humanly is very different from acting humanly, as you will see later, and it's very different from acting rationally. They are not the same thing. And we are going to cover briefly each one of them so that we know which one is probably more interesting to follow. So, first of all, thinking humanly, the idea of approaching AI from the concept of thinking humanly, cognitive science defined it as modeling the process of thinking. From engineering point of view, you're actually having a process which is thinking, and you want to imitate it. So you really want to model it. The idea is really very complicated because you have to build some sort of explanation from a situation that was a decision that was made. That thinking process, what happened? What made this decision occur based on that situation? Well, that's very difficult. Sometimes we do things we don't know exactly why we did it, and we do it right. So if you have a situation, you actually behave and you get the correct decision. If they ask you why you did that, you don't know. You have no idea. Sometimes you have skills you want to teach to other people, you cannot because you just do it like that. You have no idea. So having actually a link between a situation and a decision is very complicated. And actually, we knew that approaching intelligence from the concept of thinking humanly is not very easy. So people somehow abandoned the idea of modeling the thinking process. It was way too complicated. The other one was actually acting humanly. See somebody who is happy and somebody who is acting happy. So when you act happy, you look happy, but you're not happy. So there is a difference between acting something and being something. So here we want to see if we can have the machines act humanly. They are not humans, but they act human. This was done very long time ago, before even the concept of intelligence was introduced. This was done by this guy, Alan Turing. He did a test. It's called the Alan Turing test. He developed a computer program that interacts with people without people knowing. So the test, a person comes and he starts interacting with somebody or something behind the curtain. They have a conversation, and at the end they ask the person, was the person was the thing who's communicating with you is a computer program or a human being? If he thinks it was a human being, then the Turing test is passed. And many cases, actually, the Turing test passed. So you do not know whether this person, well, this thing is actually a computer program or it is a person. And this was done in 1950. The concept of artificial intelligence was not there, did not exist at that time, as you will see later. It was 6 years later that we started the concept. So acting humanly.
Sorry, but this can be the opposite. Instead of being the computer being intelligent, it's the human being the opposite of intelligent, not clever.
Yeah,
So either way.
with that, exactly. And actually, later on, it became like that. Later on, we had now computers that are actually assessing people. Now after so many years, we reached this point. But now, this is not really intelligence, right? This is just a test, fooling people and trying to act like a human. The concept of intelligence at the time was not there. The third approach to intelligence was actually just thinking rationally. When you say thinking rationally, we're talking about reasoning. See, like logic, right? If, like we have here, all humans are mortal, Dr. Bilal is human, so Dr. Bilal is mortal. I'm sorry, everybody is mortal. Okay, so this is logic. So when we talk about logic, formal logic is very easy to process and very easy to program. So this makes it maybe easier, much more manageable to deal with. So the approach of rationality is probably an easier approach to AI systems. Now, the history. People started talking about AI maybe like in the last 10 years, but this was like very long time ago. Actually, I don't maybe look old. The book in artificial intelligence I wrote in 2005. So it was like 20 years ago. So now, when we talk about the history, the point that was so critical was the year of 1956. This guy, John McCarthy, somehow had an idea. He organized a 1 month long conference. Can you believe a conference for 1 month? It was in Dartmouth College. It was a college. He gathered so many people, and then they had the conference. And at the end of the conference, they launched a field called, for the first time, artificial intelligence. The word of artificial intelligence before the summer of 1956 did not exist, even with the existence of the Turing test in 1950. So, artificial intelligence then, it was born in 1956. But what type of artificial intelligence? In 56, the concept was born. And the idea or the objective is to somehow make computers be like human. Why was that objective made? Because we have now two things. We have the machine. When we say machine, we mean like computer or anything like it, right? So you have the computer and you have the human. The computer is very fast. You know that, right? Very accurate. Does not make mistakes. And the nice thing about it, if it does something, it will do it all the time. It's the exact same way. So consistency. It's very reliable and it is very sustainable. It doesn't get sick, for example, or get tired or goes to sleep. So these are really good things, right? The human can actually think. We have some sort of intelligence, but we don't have these types of things, right? The computer cannot know you. You own your computer, your laptop. You use like 10 hours a day, 7 days a week. It does not know that you're the owner, right? It has absolutely no relationship with you, right? You put yourself in front of the computer, you work for 10 hours, the computer will never know that you are tired or you are sleepy, right? So the idea, if we take these nice things from computers and put them in the human being, would become something nice, right? But people realize that it's not possible. You cannot have a processor as fast as a Pentium or whatever, right? You cannot have consistency like a computer. You cannot stay 24 hours a day, 7 days a week, 365 days. So it's not possible. So they said, okay, then let's try the other way. Can we make some intelligence from the human being and just put it in the computer? That makes it more interesting and probably it's easier. Okay, so they said, okay, let's do that. When they started to do that, there was a problem. I know the problem is what's intelligence? What are we going to actually imitate from the human being that we are going to put in the computer? People did not agree in that. Some people, and this is very important. Maybe this slide is the key to AI, right? So some people said intelligence or the reason for intelligence is actually the structure of the brain. You know, intelligence is actually in the brain. And the brain is composed of so many neurons. Actually, as you see, billions of neurons, maybe trillions, with billions of interconnections. And the way these neurons are structured, it gives the human the ability to do parallel processing, and it gives the idea of storing so much data and makes people intelligent. So they somehow said intelligence is due to the architecture of the brain or the structure of the brain. So they wanted to imitate the structure into a computer. What we got now is the neural network. As a matter of fact, the correct term is artificial neural network because the brain is a neural network. We know that, right? But deep learning and ChatGPT techniques that you're using are actually artificial neural networks or ANN. So artificial neural networks think that intelligence comes from the structure of the brain, the way the brain is connected. As a matter of fact, the very first use of neural networks, something called Hopfield net. The guy, Hopfield, he thought he's going to build an electronic circuit like a brain. So he's going to have some sort of circuitry, and just having like couple of nodes made the connection so complicated. So he found out this is really maybe impossible. Uh, just simplified version of it. So intelligence is due to the structure of brain, gave us what we know today as artificial neural networks. I'll leave this to the end. Some other people think that intelligence comes from evolution. Okay, you know Darwin theory, right? They said the first initial human beings were not that intelligent. Well, they had some intelligence, but very primitive intelligence. And they said the proof that there are no inventions, they are very basic things. As you know, people evolve, intelligence evolves. So they thought that intelligence is due to the evolution, and they came up with the idea called genetic algorithms, which is very interesting. Some other people said no, intelligence comes from experience. Well, you are born with some intelligence, but that intelligence becomes more versatile and more interesting just because you accumulate some experience around your life, right? They said, okay, then to come up with intelligent system, they came what we call expert system. They are techniques. This is an artificial intelligence technique. This is another technique, and this is another technique. Some other people, and this is my favorite, by the way, some other people said, no, intelligence is due to the language. If you don't have a language, you don't have intelligence. Well, this is kind of philosophical. For example, suppose we're sitting here now, and so for a long time, let's assume we have been here for like 5 hours, somebody comes from the outside, and we're somehow worried about the weather outside. And we ask him, oh, by the way, were you outside? He says, yes. How is it outside? Is it hot or cold? He can say, well, actually, it's neither hot nor cold. What makes no sense, right? But everybody understands. So when we talk, well, it's not hot, not cold. Or somebody ask, by the way, who is this guy? Is he tall? He said, well, actually, no. Is he short? No, he's neither short nor tall. We really understand what he means. But in what we have been learning for so many years, this is an empty set. Like P and P bar, or a set and its negation, the intersection does not, it's paradox. But the language gives us a very good idea. So this guy, who will know later on who is he, said the idea is actually the language is the medium of storage for intelligence. And he said that the logic that we have been teaching, well, that we learned first, and now we're teaching our students, it's not really logical. So having something true or false is not really. And he came up with an idea called fuzzy logic. And there are, of course, other people who thought differently. Said, for example, have you ever seen these birds in the evening? Well, not evening, it's very late afternoons when they just migrating somewhere and they do these very beautiful things. You've seen that, right? Swarms, right? Okay. And you have no idea how they're actually orchestrating this. They move perfectly and they do very nice shapes very quickly. That's an intelligent behavior. But when you take a bird by itself, is it really an intelligent? Well, we don't know. The same thing for fish. If you see the school of fish, they do the same thing. Ants, bees. Those people said, well, actually, there is a group intelligence. You know, if you have a person who is not intelligent and another, well, not a person, a creature who is not intelligent, does not mean that the swarm is not. There is something called a group intelligence. So when they get together, they become intelligent. And they came up with something called swarm intelligence. This is, again, very interesting. Now, this is based on behavior. And from this came, for example, the particle swarm optimization and colony algorithm, etc. So as we see here, intelligence due to structure, assumption, intelligence due to language, assumption, intelligence due to the behavior, again, intelligence due to the evolution, or intelligence due to knowledge. And there are, by the way, many others. But I just listed here the most important one. Yes.
Like, is there any study done related to the creator's perspective point of view? For example, what Quran emphasize or talk about intelligence? For example, the faculties we have, hearing, seeing, sensory perception, like in the Sama or Basara or Goa, something like that.
Yes. Yes.
So how do they, is it incorporated or nobody ever?
No, unfortunately, it's not. Unfortunately, it's not. And actually, this is a very good question. Actually, it should be. You know why? Because as you can see, this guy came from his background, from his language. We'll see who is he later on and why he did. And he came up with something really impressive. Those people have absolutely nothing to do. Actually, this is based on Darwin, and this is based on language. If somebody actually started from whatever heritage we have, we could have came up. I have a technique. See, we have oil. Oil producing countries, right? Actually, I developed an algorithm. It's called TOSO, Team Oriented Swarm Optimization. That's actually a very nice algorithm for optimization. I was imitating the way they explore for oils. So they have like a team of explorers, team of exploiters, and it gave excellent results for open-ended problems. We're talking about, so if somebody was actually reading into the teachings maybe of Quran or our own culture, we could have had something. Some people had an algorithm based on the geography of their country. You see sand moving algorithms, in sand, dunes. So I think if you look uh, into these things, I'm sure you're going to come up with other techniques, and they could be better. But I don't think that there was anything so far. And you know, the research that.
One more comment, for example, so we do two things like neural networks and genetic algorithms. So I think the concept of superhuman, like Batman, Superman, how it was started earlier because of the Darwins and all that.
Mm,
As you said, maybe the Jah, like he will be kind of a superhuman. There is a lot of research going on in terms of genetic tailoring, how to modify a human
exactly,
genetics so he will be more powerful.
exactly. And that was actually even before 2005. You remember the sheep Dolly?
Yeah.
Dolly, there is genetically engineering thing. They did that, and maybe they're doing that. We are not even aware. So now we start with uh, uh, I don't know. I start with my favorite basically. We start with fuzzy logic. Okay. Uh, by the way, it's my favorite because I liked the philosophy of it. But there are problems that this is very good to use. But there are other problems that this is not very good to use. As you will see that AI approaches, everyone is good in one thing. There is no one that does everything. But the concept, the philosophy, this is like very interesting. I think you're going to like it too. I'm sure you're going to like it, and you will know why. So look at these two images. Okay, well, the same situation. We have a guy here, and we have a catastrophe coming from the top, and this very smart guy is telling him 471.3 kilograms of mass is 15.7 meters away and approaching your head at 7.21 meters per second. Really accurate, right? Really nice. But anyway, this guy is not going to say this fast enough, right? But assume he's really fast. He's smart and fast, right? Even if he says this way too fast, this guy will never be able to process them fast enough. And what do you think the result is? I think he's going to be smashed. Not I think, I'm sure he's going to be smashed. But again, this is a precision, right? Usually when we say precise, we feel good, right? Precision is always something positive, right? Well, here's precision. And I don't think that anybody will be happy to be in this situation. If you look at this guy, he does not sound very smart. But what he said, خلي بالك, right? Watch out. Watch out. What's the meaning of watch out? Watch out what? Why? How? When? Who are you? Right? But when you say watch out, usually it does the job. But is this precise? No, right? Do you think it's precise? I don't think so. But it's significant. So there is a big difference between precision and significance. Unfortunately, for so many years before the AI revolution, we have been teaching precision. We are not teaching significance. Why significance is more important? And you will see, especially when it is even more important. I'll give you another situation, and this is kind of interesting. You know, these are seeds. Seeds, right? هذه كوما. So I'm going to assume if I ask you, do you think this is a pile of seeds? I think you're going to say yes. Anybody has an objection that this is not a pile? كوما من الحبوب. This is a pile of seeds. Now, if we go to this, I think you still agree with me. I'm going to remove few from here, right? I'm going to remove few, and then I'll reach this point, and I ask again whether this is a pile or not. The chances are you're going to say it's still a pile of seed. Well, here I think you're going to disagree. Some people say yes, some people say no. We are not sure whether this is really a pile or not. But I don't think anyone will tell me that this is a pile of seeds. Now, we had a pile and we are taking one seed at a time, huh? And we reached here, out of a sudden, the pile became no pile. Was there a single seed responsible for changing the status of a pile from a pile to a no pile? It doesn't make sense, right? So the transition from a pile to non-pile should not be abrupt, should not be crisp. It doesn't make sense, right? I don't think it makes sense. So this philosophy brought this guy, whose name is Lotfi Zada, in 1965. He came with something that all scientists and engineers thought it's like a big no. We have been based, think our computer is based on true false, right? Binary logic. All computers are operating on binary logic, right? So one, zero, true, false, yes, no, black, white, etc. Right? He came and said, well, there is nothing like this. There is not necessarily completely true and completely false. There is something called partial truth. Now, no one in the Western world would easily agree on the idea of gray area. You know the Western world, either you are with me or against me. You are right or left. You are correct, you are wrong. It's allowed or not allowed. If you go to a banking system, the system does not allow, it does not allow. There is no use of intuition and the essence of rules. No, no. Yes or no, right? The only people who can easily believe in this are people living in the Eastern world, Easterners, like us. We believe in this. We believe that it's not just black and white. It's not just true and false, but there's something also in between. So based on this, this guy said most people think based on partial truth. So why don't we have machines also? Why don't we have logic based on partial truth? Why you have a pile and no pile? Why a person should be tall or short? Can he be both? Tall and short? Whether can it be hot and cold? Yeah, sure. Why not? Right? So this guy, when he invented the word fuzzy logic, he was having a project زي مشاريع التميز عندنا احنا والمشاريع البحثيه. That project was funded by the National Science Foundation, the American National Science Foundation. It gives, funding millions at the country level. And the Congress was once discussing cutting the budget for the National Science Foundation. They said, well, they are spending too much time. We're supposed to cut a little bit the budget. And to prove just justify this decision, said, for example, they are funding somebody who is trying to make the logic fuzzy. And they were actually making fun. Logic is supposed to be something nice, right? And a guy comes and he say, okay, I'm going to make the logic fuzzy and I need a couple of $1 million to do research. They were mocking him and they were laughing. So many years later, they gave him a gold medal for contributions to science. Not the Americans, not the West who actually believed in this guy, but the Japanese did. The Japanese are Easterners. They understood this concept and they went, remember Hitachi camcorders, and then they have the first speedy train, the washing machines. They were actually basing it on his idea. Actually, between him and them, there was a guy called Mamdani, an Iranian guy, who actually developed control techniques. The first application fuzzy was actually control system. And when it succeeded in Japan, now the Americans tried to compete and they started believing in this, and then fuzzy logic flourished. Now,
He looks Japanese.
he's actually from Azerbaijan.
Oh, he is.
He's from Azerbaijan. So, uh, he has a very beautiful statement. He says, as complexity increases, precise statements lose their meaning, and meaningful statements lose their precision. And I thought it was like beautiful. If you are talking about, small thing like this mobile, we can talk about the detail, the dimension of this ring here, the number of camera, dimension of each camera, the width. We can go to the details, right? But if we're talking about something like the universe, Can we talk now about this box that is in this corner? We're talking about universe. This becomes meaningless. So, as the system becomes more complex, significance becomes more important, and precision becomes less important.
Professor, is it like talking about intellect rather than intelligence?
Now this is getting too philosophical. Actually, both.
Both.
Yeah, actually, both. It's both. And by the way, the intellectual part is what makes me so fascinated with this. So the intelligence is hidden, but you can see later on, intelligence is born from the intellectual concept of this. So uh, if you want to deal with complex system, then intelligence is a complex behavior. So we have to go for significance. We don't go for precision. And here is an example. And this is, I usually give this example to students. See, for example, when you have a thermostat, an air conditioner, like control system, you say, okay, the ambient temperature is 25 degrees, right? And then we say, if you give like 25 degrees ambient temperature, and basic control systems, if the error becomes like epsilon, supposedly the controller is going to ask the compressor to be on, right? And this is not nice because it will be always on off. Because the air conditioner goes off, the temperature suddenly, it's automatically is going to increase. So the AC goes back on. So this is not very good. So usually we have like thyristor or what, some sort of a gap. We say no, 20 to 30 degrees are okay, right? So this is for us is ambient temperature. Now the question is 29.99 is good, right? According to this. And how about 30.01? That's not good. Do you feel 0.01 degrees? Do you feel 0.1 degree? Do you feel 1 degree? Do you know the difference between 25 degrees and 26 degrees? Actually, if I ask you what's the temperature now, I'm going to find at least 6 degrees difference. Some people will think it's 25, some people will think it's 28, 29, some people think 31 even. I'm sure what you're thinking now. So, how can this be ambient and this one not? So this sharp transition, this is common sense. This is a classical. This is what they teach us in math, right? They say, for example, the set of big numbers are numbers greater than a trillion, right? Set A is set of all numbers such that A is strictly greater than trillion. Trillion minus epsilon, big number? No. But a trillion and trillion minus epsilon are the same. All right. So can one be a big number and belongs to the set of big numbers, and the other one does not? So the idea of crisp or classical sets are kind of weird. They don't make too much sense. But our computers so far are operating on this. When you work with logic and all DLDs, circuits, etc., it's like XOR or etc. 1, 0. It's like that. Lotfi Zada, he came with the idea of fuzzy sets. Says, no, sets are not like that. Sets are like this. So, if you say cold, I tell you from 0 to 10 degrees, I am sure it is cold. While from 10 to 25, it gets better as we go a long way, right? Again, the medium, I know ambient temperature is 25. I think everybody agrees 25 is a reasonable reference, right? But as you go away from 25, left or right, if you go to this side, you're going into the hot area. If you're going to go this side, you're going into the cold area. But definitely 40 degrees and above, it's very hot weather. So you notice two things here. Number one, going from one set to another is smooth. It's not sharp. Makes a little bit more sense. And another interesting concept, you can actually belong to more than one set at the same time. So a temperature like 15 degrees, is it cold or ambient or hot? Well, it could be all Well, 15 is actually medium with a degree of membership 0.3, and at the same time, it is cold with a degree of membership of 70%. It's slightly more cold than medium. Makes sense. That's why when somebody comes and say he's not tall and not short, we understand it because it's based on this logic. And if you use this system to come up with decision making for control systems or whatever engineering application, oh, there is a huge difference between the impact of this and the impact of this. That's why the first camcorders, when they came along, if you are recording, before, like if you move, you see shake, right? When fuzzy logic came, the shake you don't see. You move and you don't shake because the camcorder would know whether it's you who moved or the subject because it's not yes or no. So there is some sort of smoothness in the decision. So this is really the essence of fuzzy logic, which are fuzzy sets. How can these be?
But the problem was not solved if only you shifted it from 20 degrees to 10 degrees.
No.
And the same problem still exists at 10 degrees.
Oh, here you could
the
do.
problem at 20, whether it is a little bit after or a little bit before. Now it's just the same.
No. You could do the following. You see that medium here? Take it all the way here. There is no problem. The reason why I put it here because for me, I'm sure 10 is called. But if you don't want to do that, fine. Here is a membership function like this and like this. So you always have, and this one you could do the same thing like this. You have the choice. If you want to get technical, and as you will see, I'm not getting technical at all in the whole lecture. But if you want to get technical, you can choose any function as long as it is monotonically increasing or monotonically decreasing. That's the only criteria. You can use like this. You can use Gaussian. You can use trapezoid. Use anything. And the nice thing that the decision there is not influenced big time with the choice. The influence is not that critical. Clear؟ سو ما عندك sharpness. أنت تحكي على النقطة هذه صح؟ لا خلاص. Maybe I chose a bad example. Here, straight line. Could do that. And I use this because I know I don't want to make decision based on 5 degrees being possibly medium. And I don't think it is medium. But it's you. If you think you want to start from here, just go ahead, do it. You will have absolutely no effect. Now, how can this be implemented? We are not going to, unfortunately, our computers are already based on the Boolean logic, right? Binary. You're not going to come and say, okay, throw all these computers, and why don't we just have other computers work on other? It doesn't make sense. What we can do, we can go around it. So we have our system that takes measured variables, which are numbers, numerical, and then it gives command variables that are numerical. Say, for example, an air conditioner measures the temperature in the room and then compares to the set temperature. These are all numbers, right? And then sends some signal and then gets an output, which is the outside temperature, and then makes decision according to that. So numbers, system, numbers. Okay, this is a machine or a computer. How can we use fuzzy logic? Very easy. We take these numbers and then we fuzzify them. So we change the numerical values into linguistic values. So temperature of 25 becomes medium, high, low, language, right? And then since we have now linguistic variables, I could use rules that are very easy. If the temperature is high and the humidity is high, then the compression is high. If the temperature is low and the humidity is high, then the compressor level is medium. Easy to make, right? These rules, I can make them in languages. And then I come up with a decision. The decision also linguistic, which is the compressor operating level. Is it high, medium, low, between high and medium? Linguistic, right? Now, the computer does not understand that. And then we defuzzify. So we take the decision from a linguistic variable to a numerical value. So we're bypassing, instead of making our decision system based on numbers, we take the numbers, fuzzify them, make linguistic rules, take a decision, linguistic decision, defy it, and then send it to the computer. So this can give us the possibility of making intelligent decision based on language, not binary logic, without having to change the structure or the composition of machines. Okay, so this is how actually it is done. There are details that probably not the time for them. And here's how we falsify. Say, for example, your sensor sensed 22 degrees. So the compressor takes 22 degrees, and then 25 minus 22, the error is 3. 3 goes to the amplifier or controller, and then the compressor, etc. Now we're not going to send 22. We're going to take, we chose, for example, these membership functions, and then I say 22, well, it's 24% cold, and it is 0.85% mild. So if we say, if the temperature is mild, then the compressor is high, I'm going to say the compressor is high only to a degree 0.85, because the decision, the degree of truth of the decision is a function of the degree of truth of the inputs. So that's how we're going to use. As a matter of fact, what we see here, we call it degree of membership. It's something between 0 and 1. If it's 1, then you fully belong to that set. If it is 0, you fully don't belong. And anything between is partial belonging to the set.
Whether these both should be total, should be one. Like
No, not necessarily.
for
No.
the red, it's on a scale of 0 to 1.
Exactly. But the sum of them does not necessarily, uh, you can make them like that, but it doesn't have to. Okay. So the fuzzy inference maps the falsified inputs that we had, like temperature high, low, pressure high, low, speed very fast, very low. Use language, right? And it hedges with it. Falsified input to the rule base, which has your rules, and it produced a falsified output for each rule. Because sometimes you have the situation activates more than one rule. So the pressure is high and the pressure is medium. There is a rule for high and there is a rule for medium. There will be two rules. Sometimes you have 4 or 5 rules. All of them are active, and everyone is giving a different output with a different degree. What you need to do, take all and accumulate all the fuzzy outputs. The result is a decision space. You defuzify it, maybe using certain like center of area method or center of gravity or weighted average. There are many techniques. And then you get one particular decision space. Now you say, for example, based on these things, we came up with the idea that the compressor should be medium high, like that, right? So medium high, what does it mean? The computer does not understand medium high or the air conditioner. So we need to have to defuzify medium high using the same membership functions into an actual voltage level, for example. Okay. So here's a clarification of this. Say, for example, you want to design an intelligent system for medical diagnosis. Okay. You know, when sometimes you go and you do this medical analysis, and they tell you that you have blood sugar is this, and then millimoles, and you have, I don't know, sodium. You know, this list they put, right? And they have normal level from this to this. And maybe if you have done tests before, sometimes your number is just like just slightly before the normal level, and you want to see whether is this good or bad. You know, should I worry or I am okay? You know, you say if kids they like move the the lower level by epsilon, you'll be inside. Right? I'm sure you'll be happy. It's just nothing, right? It's small, but the fact that you are outside a range that they put sometimes makes you worried a little bit. Okay, fuzzy logic can solve that. By the way, fuzzy logic can make more people more happy. So, say for example, this is a diagnosis based on classical logic. Normal. They say if A is greater, assume A is sodium or sugar or glucose, whatever, just see. If A is strictly greater than 3.2 milligram and B is strictly less than 0.07, for example, millimole, and C is less than 15, then the patient has anemia. The doctors work like that, right? They have normal levels for certain tests, and if this condition is satisfied, then the patient has anemia. By the way, sometimes they say he has anemia just because he had like 3 point, I don't know, 201 or something like that, you know. It's not really having an anemia or not having an anemia should not be decided on the basis of like fractions of numbers. Okay, so sometimes the decisions like this are not really, well, it's not sometimes, they are not intelligent decisions. What you could have done, if A is big and B is very low and C is low, then the patient has a mild case of anemia. I think if I go to a doctor and he gives me this statement, obviously I'm going to be happier than having an anemia. Having a mild case of anemia is better than having anemia, right? Anemia is not a big deal anyway, but it makes you more happy. Yes, better.
Some diseases have to be decided to a mild of this has to be a mild.
So, yeah, some diseases, yes, sometimes some diseases don't, right? But even if you, those who are, I think I know what you're thinking about. But even that, there is a big difference between at its starting, say for example, phase or a later phase or a developed phase. دائما يعني situations are kind of different. So we can develop fuzzy sets based on this. As a matter of fact, I don't know if you know Abdullah Sharbat or not. His project on monitoring of in the intensive care units, he had like 3,000 rules like this, and it monitors patients who are in intensive care units with 5 vital signs. So we're talking about emergency here. We're talking about intensive care. It's not even emergency. Things when they are done like this, doctors tend to have false alarms. Say, for example, if the oxygen level is below 94, then set an alarm, right? So 93.9999, the alarm will sound. 94 is going to be quiet. So these false alarms, they are nonsense false alarms within the intensive care unit is really perturbing, right? Because you'll have more than one patient and sometimes I don't even trust them. If they had something like this, things will become more peaceful. Okay. So anyway, we don't want to spend every area. I think you can go even deeper. I'm trying to just give you general ideas. I don't even know the time. كويس ما لسه في وقت صح؟ Okay. So remember somebody was telling me about autonomous cars. Well, actually, they even use that for trains, as I said, in Tokyo, for example. Uh, as an example, suppose you want to have an autonomous vehicle, a vehicle that is actually going and following another vehicle. You don't want it to crash, and again, you don't want it to go too slow to be safe. So, say for example, we take the distance to the car in front and the change in the distance. So these are the two parameters we need, right? How far am I, and how fast I'm approaching, right? And then my output will be actually the acceleration of the car. A rule could be like this: if distance is small, we are very close, right? Then slow down. It doesn't matter what's the rate of change of the distance. If I am too close, I should slow down. See, very short rule. But if the change in distance, if change in distance is very small, that means I'm like steady speed, then keep speed. Another rule, if the distance is small and the rate of change is high, then brake. You have to brake, right? So rules like this, anybody can make. But if you're going to make them in numbers, then you're going to say if distance is less than 3 meters and acceleration is later than more than like 50 kilometers per or speed 50 kilometers per hour, it becomes very complicated to come up with these rules, right? But if you make them linguistically, things are going to be easier. Notice here, fuzzy variables in blue and fuzzy sets on red. So this is fuzzy variable. Distance is fuzzy variable. Rate of change is fuzzy variable, and the fuzzy set, which is high, low, etc., is given in.
So, so Mr. Ad, but if you could go back to that example, this is Sorry to interrupt, but this would create problems
Like,
because in transportation, I teach transportation. We have a set rule that you have to keep 2 cars distance between you and the guy in front of you.
sure.
Now, if there's an accident, someone might say, "Well, the distance is too big, while it is only half a meter." While the rule, you have to put exact rules to follow and then determine who's at fault and who's not at
Yeah,
fault.
but
So
again,
this one doesn't work all the time.
say for example, actually, if you attend next lecture, we may even talk about application in traffic engineering. You know, when we say for example, traffic rules, they say you're supposed to leave the length of a car for every 10 kilometers of speed, right?
Something like
Something like that. So, say for example, you said I'm moving at certain kilometers per hour. I have a distance of 30 meters. So 30 meters is different from 29 meters. Who's going to say this is 30, not 29?
that.
But you can say whether this is enough distance or not. Like a person who is watching can say, well, this guy did not leave enough distance. It's easier to do. But how much that distance? Was it 7 or 9? I don't know.
I agree with you. But small to someone is big to another one. That is the problem, and this is almost contrary to what I teach in my classes. In my classes, I always say, "What is the temperature?" Someone will say cold, hot. This I tell them, don't we engineers? We always talk about numbers.
Exactly.
Give me the number,
Exact value.
and don't give me these words because these words are not
That's
very.
precision. That's precision. That's what we're trying to avoid these days. But the
And
solution.
I'm starting to get a little bit, I
Worried.
would say, not irritated, but I say, one, I have been teaching for 30 years this concept. Now, all of what I have been teaching is
Ah, it's
wrong.
okay, no problem. But okay, I give you the good news. The good news that the person, that the thing that's going to drive this car is not a human being. It's going to be a
Yes.
machine. So there will be, actually, we're earning the consistency of machines. So if you think that 30 meters like a long distance, and another person thinks that it's short, we're not talking about people now. We're talking about machines. So consistency is guaranteed. I give you an example. بعد إذنكم, I like those people in traffic engineering. Say for example, when we talk about congestion, right? Right? When you have the capacity, right? A, B, C, etc. Sometimes you don't know whether you are in the B or in the C capacity level. Just but you have to count, right? The number of cars in a given area. It doesn't. That's why most of the police officers, when they don't really have the means to do a very good decision. Now, suppose, and it was done, by the way. Suppose you have just a camera and you have this particular distance, and you have a system that measures these cars with those occlusions and the shadows and all the stuff, and it tells you, well, this is a high congestion. It's not necessarily A, B, C, D, because it can be anywhere between B and C. So you can do preventive measures. You can like close ramps in the ramp metering, right? You do ramp metering. It's much more versatile. It gives you much more dimension for the decision. But if you say, if you are in C, then close the entrance to the highways. C means you have more than 1,000 cars per kilometer, right? 1,000 cars, you close the ramp. 999, you don't. Doesn't make sense. Yes. ممكن اقفل عشان بعدين نشوفه. Yes.
Extreme weather. Conditions are not as like we have the standard readings for ideal conditions. So these models are very dynamic.
Yes.
You can incorporate as many things as you want, like speed or bad weather, because the distance is for ideal situations.
Exactly.
When the weather is worse, that distance is minimized.
Exactly.
How do you
As a matter of yes, good point. By the way, I did not want to go to details. For example, for these cases, I can have more inputs, right? It's not just distance and acceleration. It's even the type of the road, the type of the car. You can weather conditions, illumination. You can do all the things. And another thing, you can even have more membership functions. It's not just low, zero, and high. You can have very, very low, low, high, very high, very, very. You have the flexibility. You can do anything. And the difference between having like two inputs, two membership functions, and 10 inputs, 10 membership functions is just like 5 minutes on the computer. So when you were talking about MATLAB, so the idea is automated. So you have the flexibility to really incorporate everything you want with the possibility of adding the dimension of significance to the precision.
On that subject, it changed from 13 from 10 to 7, so it's other way around.
And which one?
The SOs, they changed
Ah,
they try to make it more simpler than more being more
Sure,
complicated.
simple or complicated. I know.
see, simpler, complicated. So we covered the first. That was the first uh, approach of artificial intelligence. That approach is really good for problems that have to do with decision making, maybe control systems, fault detection, fault diagnosis in general. This system is very good. Okay. Now the other one is, well, most of you already have heard and even used, are the artificial neural networks. Okay. I'm using here, like everybody says, neural networks, but they are called ANNs, and means artificial neural networks. Now the first approach, well, fuzzy logic, was trying to bring intelligence using the language, okay, or using the qualities of language. A neural networks is trying to bring intelligence using the way the brains are actually structured. We're trying to model somehow the brain structure. I'm sure you took this in anatomy when you were in high school. You remember this? This is a neuron, right? So we have this cell body, the soma, and we have the nucleus. We have these things, these branches called dendrites. They are very important. And then we have here the axon. And then these things are called synapses. These are the points at which one neuron is connected to another, right? So this thing here, if you have another neuron here, so they will be connected through these points here, and they're called synapses. Synapses are the one of the important. There are neurotransmitters. I don't want to get into details of biology. Neurotransmitters, they go through these synapses, and the actual strength is not uniform. So you can have very strong connection, or you can have very weak. So humans store information by adjusting the way the strengths are made. Okay, so as you can see, uh, we are trying to model the way the neurons are built, and the way the brain is structured with like many neurons like this. Now, an average person has about 100 billion neurons. When you talk about 100 billion neurons, and every neuron will have so many connections to other neurons, the number of connections on the average is 10 to the power 4 connection per neuron, and we have already 100 billions. So the number of connections, these synapses that we talked about, is about 1,000 trillion. Now that's bringing us back to your question. So if you think about it, it's kind of, you know, interesting, you know. So we have like 1,000 trillion synapses. This is a very complex system. That's why people actually forgot the idea of modeling the process of thinking. And they said, okay, we're going to image. These are actual things. See how they are connected? This is like a very enlarged uh, images. So the system is extremely complex. Now, they said, okay, let's start with a very simplified version. And this is just one neuron. See that neuron we're talking about? This is an artificial neuron. It's not real neuron. An artificial neuron is modeled like this. Just this is the soma. Remember the soma we had? This will be the output. And we're going to have many inputs. So these inputs we get into the soma. And we have here an activation function. The activation function could be simple threshold. Basically, right? If the sum of this is greater than a certain value, then you fire. That means 1. Otherwise, it's 0. And here we have weights. So V1, V2, these are weights. These weights are actually imitating the strength of the synaptic connection. That's how it is done. Now, when we put numbers here, we kind of train the network in such a way that puts the right weights here. So whatever input I put here, I get what I want as an output. And it worked. So they put like an OR gate, and the logic OR. It was really nice. Just one neuron will model the OR. The AND, etc. The NOR, the NAND. People start to be very happy. And then one guy tried the XOR. Okay. So here, for example, just before I get the export, see, for example, this activation function is 1 if the sum of the inputs multiplied by the weight is greater than theta. Put anything here you want. Otherwise, 0. So say, for example, two inputs, an AND gate. 0, 0 will give me 0, right? So I will try to find what are the weights that give me 0. And then 0, 1 will give me 0. If it doesn't give me 0, I have to adjust the weights again to give me 0 also for this case. 1, 1, I'm supposed to get 1. If this is not 1, I have to adjust these weights. So that gives me the right output for every case. So we're going to train. And there is a rule that makes you train and converge to particular solution. So when they did the AND and they did the OR, the NOR, people really thought this is really interesting because uh, one neuron did this. So like 2 or 3 or 4, which is going to be very nice. One guy tried the XOR problem. See the XOR? 0, 0 is 0, 1, 1 is 0, and then 1, 0, 0, 1 is 1. There was absolutely no set of weights that could give this result. And people started working on trying to find out why. And they realized that the XOR is a linearly inseparable problem. So if you put the plane, see like 0, 0, 0, 1, say for example for the AND, you can draw a line to separate the 1 from all the zeros, right? The same thing for the orange, but the XOR is actually 1, 1, 0, 0, right? You cannot have one line to separate. You need two lines, right? So they said, okay, two lines. Let's try two neurons. When they did two neurons, they were able to model the XOR, and that's the first time the neural network structure became. It used to be called the perceptron, by the way. There was no neural network. It was a perceptron, the Adel, etc. And then started to become a network. So for complicating the problem, you have more neurons. And later on, we started to have more layers, actually. That's how we reach the deep learning now. Okay. So how we train these neurons? There are three ways of training. There is supervised learning. So you give the actual input and the actual target. So the random weights are selected, and then you see the output of the network. You compare it to the target. You get an error. You feed back the error using some rules, delta rule, for example, and you adjust the weights. Mathematical technique. So that's called supervised. So you're actually giving the way the network is supposed to behave. And then you stop training and you just give it the input and it will work by itself. Another one is called unsupervised learning. Unsupervised, just give it the data and let the network find the features or the patterns in the data without you saying anything. Okay, there is something in between. You don't give all the targets, but you don't leave the network alone. You come in between, and that's called reinforcement learning. So you give it the data, the network does the performance, and then you say whether it was good or not, right? So you give some sort of a grade. Your result is, deserving this grade. That's the quality of this. This is how ChatGPT is trained. Right?
I was about to ask.
Yeah, ChatGPT is using this particular technique. Dr. Hafid, you had something.
Professor, the word learning is a substitute for intelligence, or it has a different meaning?
AI,
Yes.
AI is intelligence, but artificial intelligence.
No, but learning is a substitute for intelligence, or intelligence is different and learning is different.
Well, you're talking about one of these points here. Which point?
No,
So we are using word learning instead of intelligence.
No, no, learning. Actually, what I mean by learning, I mean training. Yeah, just training. How you train the network. Learning is from the perspective of the neural networks. The training is from the perspective of the design. But I mean just the process of the training. So these are the three different training aspects. This is the XOR problem. This is what ignites the idea of having a structure or a multi-layered structure of neural networks. So the first time we start to have this technique, and after that, as problems became more complicated, we started having more neurons, and later on, even more layers. So this is how the neural network is structured. So this is your input layer that has all the inputs. This is the output layer that has your outputs. And inside is a just hidden layer to give us the idea of having more weights to adjust and make the network do whatever we want to do. Okay. Later on, we had the concept of deep learning. ChatGPT is a deep learning algorithm. So now we want to clarify some concepts. You know, machine learning, artificial intelligence, neural networks, deep learning. You hear all these things, right? So we want to see how these things are actually related to each other. And this is important, just to have a complete picture. You know, we have like the area of artificial intelligence in general. This area, حياك الله. احنا بنخلص وانتم جايين. We're recording. So I have to be, yeah. So we have the area of artificial intelligence in general. Okay. Machine learning is a set of artificial intelligence. Machine learning is anything that allows the machine to learn. But not all artificial intelligence techniques are machine learning. For example, we're going to talk maybe in next lecture about expert systems. Okay, expert systems are artificial intelligence, but they are not machine learning. Okay, now we talk about machine learning. It's not just a neural network. Fuzzy logic is machine learning, right? Genetic algorithms, particle swarm optimization, and calling algorithms. All these things are machine learning techniques. They are not neural networks. Well, a neural network is just one type of machine learning. Neural networks and deep learning are not exactly the same thing. Neural networks are just the general neural network structure. A neural network with many hidden layers is a deep learning neural network. So the difference between neural networks and deep learning, this is a more complex neural network architecture. Because normally, with just one hidden layer, you can solve most modeling problems. Actually, I can say with one hidden layer, you can solve all modeling problems, irrespective of the complexity of the model. And I can claim that, okay? But when we're talking about language processing, natural language processing, things are becoming way more complicated. Then you will need more hidden layers. Actually, the transformers are required to have more than one hidden layers because there's processing phases. So you get into the circle of deep learning. So deep learning are neural networks with more than one hidden layer.
So ChatGPT or any other AI bot, they are using deep learning techniques.
Exactly.
All of them.
Uh,
The transformer part is there, that is why, right?
yeah, all of them use deep learning because all of them use more than one hidden layer. Huh?
Can they not put deep learning in one part?
Deep learning is,
One part of the application.
of course, yeah. It's more complex. So if you are doing natural language processing, it's very difficult. I don't want to say impossible. It's very difficult to get reasonable results with just a single hidden layer. You need more than whether you are using transformers or radial basis function or I don't know, recurrent neural networks or delayed neural networks. There are many techniques. You still need more than one hidden layer. Okay, so it becomes a deep learning approach. دكتور ريان لو قاعد الاخر قول لي انت بقى اخلص ها
نص.
اخلص ونص يعني اخلص النيو نتورك ونوقف صح؟ اوكي سو اكشلي نخلص هذه وخلاص. So Uh, سؤال الآن, when is the right way or the right time to use neural networks? See, remember we said if you have decision making, use fuzzy logic, right? Diagnosis, etc. Neural networks is actually good for pattern recognition. All pattern recognition problems. Say, for example, face recognition, character recognition, uh, navigation system, because kind of modeling, generalization and prediction, forecasting, for example, pronunciation, net talk. If you know, net talk is based on neural networks. Language processing, like ChatGPT, BARD, and that stuff. So neural network can be very useful in these types of things. Now, this is, I'm going to assume the responsibility for this statement. I always say it and nobody challenged me. In brief, any problem needing modeling, generalization, prediction, interpolation, or extrapolation, irrespective of its complexity, a neural network can solve. As simple as that. This is how powerful the neural networks are. And that's why actually you are being impressed with the chat GPT, right? By the way, chat GPT now, it's called low AI. You know, we're talking about very low level of intelligence. We did not get into, maybe in like 20 years, where now chat GPT is less intelligent than us. Maybe a few years later, maybe 5 years, 6 years, we're going to have intelligent systems very close to our intelligence. 30 years from now, we're going to have systems that are much more intelligent than us. So we are now in the AI era. We're at the low intelligence phase. So don't get too impressed with ChatGPT. Okay. It's going to be even more fascinating. I think this is probably a good place to stop. Uh, I don't know, this is technical a little bit, but when you train in neural network, you have to be slightly, maybe some of the students would like to use this. See, when you train neural network, it's just like you're training somebody. So if you don't give it enough input and output targets, you may not be able to get a good generalization. You may get a response like this. Just you did not give it enough data to learn. But if you give it way too much data to train, it will actually reproduce the whole thing exactly. Well, these things are, the actual function is like this, by the way. These are like noise, measurement noise, etc. So if you do excessive training, the neural network will even learn the noise and the disturbances, which is not good. The right way, with proper training, you actually learn the actual function, not the actual point. So here we're doing under fitting or under training, and here we're doing overfitting and overtraining. The nice thing is when you do in MATLAB, you have data, you can divide into three: training data, validation data, and testing data. Training data just to train. Validation data, it makes sure that your error is decreasing without going to do this. Because if you get into this, you find your error is decreasing and your validation error is actually increasing. That point you have to stop. And the testing data is actually a data that the neural network has never seen before, and you can test whether it's actually generalized enough or not. These things are like push of a button, by the way, in the MATLAB application. Good point, I think. So if there is another lecture, we'll talk about genetic algorithms, and we'll talk about expert systems, and we'll talk about evolutionary algorithms, basically ant colony algorithms. Something nice, by the way, to see. Oh, okay. Next Wednesday from 10 to 12. If, people who come here will get prize, all right? If you have questions,
So this chat GPT, it's still training itself, or because chat GPT, I'm talking about Siri. It's
Hey.
offline since September 2021, right? All the data was there. After that, it's not online. So is it still training and improving itself, or
ChatGPT public, no, it's still stuck on the data of 2021, as far as I know.
yeah,
Well, the professional one, I think it's
it's online as well, like BART?
yes,
Okay.
yes. That's what Microsoft said, actually. The reason why, by the way, this is something good and bad about it, remember. So when you train when you let your network train itself online, there are certain things that you can, invalid data, things like that, right? So if you do it an offline, you can actually somehow check the idea of ethics, the accuracy of the information, but it makes it not up to date because it will not give you anything based on like last year. So that's what people are trying to resolve now. And and I think one way of resolving it is the ChatGPT enterprise, which means that for certain sensitive areas, for example, for medical areas, they will have some sort of an endorsement for all the information to be used for training. They don't just use the open internet resources. They use just authentic resources for religion, the same thing, for education, another thing. They're trying to resolve. I don't know if they can control. I don't think they can control. Things go beyond. Sometimes this intelligence system, they do things you don't expect, and we're not supposed to be surprised because actually sometimes you have data, you have no idea what's in the data, and you're actually designing your network to discover features in the data, feature extraction, for example. So you to discover, so you know that the neural network can actually discover things that you cannot see. And one neural network, an intelligence system, does something that you did not expect, you get surprised. Does make sense? You know it can do that. And the more sophisticated it is, I think the more dangerous it's going to be. I think so.
I have another question. Like we have self-driving Tesla cars, right? This ability is there, self-driving. So they are using some sort of artificial intelligence. I know they are using control systems for sure. Are they using any sort of artificial intelligence?
Yeah, the later application. I have this example at the end. Say, for example, Tesla and then Uber also, they are developing autonomous vehicles. Autonomous vehicles don't need to be intelligent. Well, the first thing was done. We have a project in control systems. It's an autonomous vehicle. It has absolutely no intelligence. It's just a proximity sensor, and then it can navigate, etc. But now you can put in intelligence because you can have it. You can have more intelligent navigation, and you can have even more impressive performance. Because if you do the classical things, you may have limitations on maybe the speed and the processing. But with intelligent aspects, you can have much more complex decisions. Now, most intelligent or autonomous vehicles, they call them, are based on intelligence. And the pioneering project is a project joined between Tesla and Uber.
Okay.
So we'll talk about it. And it's actually supposed to, ChatGPT consider it one of the best 5 applications of AI. You know, I asked ChatGPT what are there are many applications. I asked it and Bartu what are the 5 best applications of AI. They gave me the same answer almost, right? Of course, ChatGPT is one of the best applications, and he told me that he's one of them, you know, and one of them is actually the intelligent autonomous vehicles. Any more questions? Uh, sure, sure. So, Kulin, you had a question, right?
What is the minimal thing that I have to implement in my code so I can say this is AI? My first question. Second question is when I have embedded system, can I say it is artificial intelligence? The code that I wrote in that.
No, no. The first question, you don't really have to write the code. You could use just a built-in program, right? In MATLAB, right? A code cannot be intelligent unless it has the concept of actually being able to learn. So does it learn? Can it be trained? Can it generalize? If it cannot do that, we cannot call it intelligent. This is just a code. So an intelligent system, it has to somehow satisfy the concept of learning. If it doesn't learn, um, it's not intelligent. It's just a system, classical system.
So what about the embedded system that has sensor? What, for example, light sensor, photo, resistor, and servo motor that for example, compare some lights, luminosity, and process it to some orientation of the center motor. So we cannot say them as artificial intelligence,
No.
but it can be smart, but not artificial.
You can make it smart.
Yeah.
You can make it smart if you take, for example, if you have your photo sensor, etc. You get what you desired lux, lux, and the actual, and then that error. If you feed it into a system that is based on physiological neural networks, etc., then that's an intelligent system. If you just take the error through an amplifier or a gain or whatever, a potentiometer, and give it to a servo motor, it's just a classical system.
PID controller.
It's not intelligent. You can have an intelligent PID control, a fuzzy PID control. But PID as a PID, it's still classical. And even PID that is designed using an intelligent technique is not an intelligent PID. It's a PID that was designed intelligently. But it is a classical because at the end you're going to put a value of KP and a value of KI and a value of KD. They never change, right? We don't know whether you brought them by yourself or trial and error or Nicholas criteria or an AI approach. At the end, it's just a fixed value, right? So that's not an intelligent system. A system that does not change and adapt and learn for other situations cannot be called intelligent system. Okay? Any more questions? Yes?
Is it possible to create an AI cybersecurity counterattack their
Yeah,
hacking?
it's possible. See this one? Computer scientists do it much better than us. And these are there are many applications. These are one of the most important applications. Engineers cannot really compete in these types of things because you are required to have an extensive knowledge in actual cybersecurity, and then an extensive knowledge in artificial intelligence, and an extensive knowledge in application development to link this to this. This is a computer science problem. See, engineers can actually say there are certain things we cannot do. So this is one thing we cannot do. Any other questions?
What is the role of engineers in the field of AI?
What's
The role, the role.
the rule?
Yeah. So how they differ, the difference between a computer scientist and
And we develop actual systems. It's not they develop codes, computer programs. So they have an application. Eventually, it's something on a mobile. We have something that moves. We have something that works in the industry, in the in I don't know, in electronic devices, machinery, cars. You know, when you develop something for a car, it's an engineering problem, isn't it?
the idea is applying the concept of AI.
Yeah, they go more in engineering, go more for the development of prototypes or actual things that work with systems. You actually design them. Computer science, they work on things that are on computers, applications. Eventually, they develop software. We develop product, physical product. So our contribution is physical, and their contribution is soft. Okay. Bienvenue. You don't have any question? No? Okay. So I should say thank you. Yes.
Is there any kind of artificial intelligence that can learn by itself?
Yes. Self-learning. They call it self-learning. Self-learning neural networks. They just learn. They teach themselves, and yeah. See.
ChatGPT is self-learning or
No. ChatGPT جاي في النص. ChatGPT يشتغل وفيه technique that tells it well you did a good job or not. Gives it a grade. It does not tell it what's the right thing, but based on what it does, it gets a grade.
sometimes you ask ChatGPT these things and he said apology or he gives why it's just a rule.
No, actually, ChatGPT that you are using, it's already trained and done. They trained it, and they finished, and now it's actually put to use, right? It does not say because maybe the information was not available when it was trained. The information was not available, or maybe the way you asked the question it was not very. By the way, ChatGPT is trying to be politically correct. Say, for example, if you asked about uh, how is the Islamic University education level, it cannot tell you whether it's good or bad. It's going to give you something. Islamic University is I don't know, university that has objective. It gives you information already we are publishing, so it cannot make a decision that is very strong. They are trying to be very culturally sensitive. That's why sometimes it's useless to get opinions from ChatGPT. But it's nice. You can ask it for a problem for control systems, and it will give you problems, give you a solution. These things are okay. You know that we do that, right? And if you say this is difficult, you say it's ChatGPT. Okay?
So as engineers, where should we start for the to be like to use an AI in our like for society? So what's your advice so we can start by learning one step for the for as beginners?
See, long time ago, uh, people are called illiterate if they cannot read and write. Right? After a long time, said people are illiterate if they don't know the basics of computers. Right? And then people are called illiterate if they really don't know how to use advanced apps and etc. for computers. A couple of years from now, people will be called illiterate if they don't know artificial intelligence, which means you start reading and learning AI and use it anywhere. You know, it's like somebody. Imagine somebody 30 years back. Somebody is asking, "Should I learn Windows or Excel? Where should I start? Should I start from Word or PowerPoint?" Imagine somebody's asking the question now, right? Doesn't make sense, right? You're supposed to know all of them. You have to know AI, you have to know all the approaches, where every approach is being used, use all of them. Because 5 years from now, there will be other things that come along. And if you don't know these things, you will find it very difficult to learn the other things. You will find yourself disconnected. Like somebody now, if you ask him who's like 40 years or 50 years, your grandmother or grandfather, if you ask him to use the application of the mobiles, they will say no, we can't, we don't want to, we cannot learn them. And this is true, right? Because there were so many advances and they were just not willing to get into it. So after a long time, you'll find out that the gap becomes very much, and you'll find that you have a lot to learn. So from today, actually, you already started, right? So from today, start learning. By the way, there was a statement that I wanted to say and I forgot about it. AI is more powerful than you think. No matter how big is your imagination, AI is bigger than that. And AI is much simpler than you think. People think that like it's very complicated to develop AI systems. It's not. It's really easy. You just learn about it. Use MATLAB and you'll find everything is very easy to use. Okay? So maybe we'll see you next time on Wednesday at 10 o'clock. Well, thank you for your participation.